Welcome to the session. Greeting of the day. In previous classes, we are on the discussions of magnetic particle testing. In the first previous classes, we have done about the introduction of the magnetic particle testing. Then we have started to give about the working principles of magnetic flux leakages. These things we have covered in the previous classes. In continuous with that, let me move towards the procedures of the magnetic particle testing, how they are doing this process with understanding of the magnetic flux leakages. You see, this is what we have already seen in the previous classes, such as the introductory part. It means we are dividing the surface cracks and subsurface cracks. Likewise, we have divided the surface defecting cracks and subsurface defecting cracks. On that, our interest is magnetic particle testing. This is how we have divided the topics over there. It means the NDT topics has been divided into much more 8 categories. On that, we are concentrating on magnetic particle testing. You see, we are going to talk about this types of magnetic particle testing. Not types, it is steps of magnetic particle testing. So they are mainly importantly can able to divide into 5 steps that we are going to see in this today's class. 5 steps. Number 1, part preparation, component pre-cleaning, degrazing and demagnetizing. This we have to do before starting of the testing process, and even after at the end of the testing process we have to do cleaning, because we are going to use the magnetic particles over there. So it should not residue over there, therefore we should make the cleaning process. And in the first inspection, there may be the dust particles, grease particles, those things we have to see. So one by one we will cover now. So it means the first one is part preparation. Second one, it means the working principles what we have done. Introducing of the magnetic field on the specimen. Then application of the fine magnetic particles. You see, application of the fine particles. First we have magnetizing, and then spraying the magnetic particles over there. Then at last we are going for the examination. It means it's nothing but a inspection. So after completing all these things, as I have already told you, we are doing the magnetizing process. Therefore, we have to do the demagnetizing, otherwise it will residue back inside itself. And then the next process we can't able to do in the industry when we are anything conducting material, magnetizing material, when you are getting in contact, it will attract. If it is not demagnetized, it will strongly attract. So those property which naturally will be there for ferromagnetic material, we are additionally giving magnetizing, that we should remove back. So that is called as a demagnetizing of the component. One by one, there are totally 5 steps. One by one slowly we will look over. Number 1. See, this is what the principles of magnetic particle instruments we have seen in the previous classes, that it is forming perpendicular to the flow of current, right hand thumb rule. I have told you, right hand thumb rule like this. So the current flow in the upper direction or any direction, perpendicular on the path of fingers, the magnetic field will be there. And the current flow in the thumb direction, magnetic field will be in the finger direction. That is what I have told you. It means what I have covered. Right? You see, so these are the various simple images shows the leakages. So when it is magnetized, all the flux lines will be in the same direction. But when that non-magnetized condition, due to grains, all will be in the different direction. So all we are trying to make the strong field by making the magnetizing, and therefore the strong field created when it is in the one direction. So we understand that we are when it is in the one direction component. So this is how we are able to do this magnetizing inspection process. We enter now. Step 1. So it is nothing but a part preparation. First step 1, we are concentrating on the part preparation. So what we are doing here, you see, the components the same. I have just have typed here the definitions: pre-cleaning, degrazing, and demagnetizing. When inspecting a test part with magnetizing particle method, it means magnetic inspection method, it is essential for the particle to have an unimpeded path for migrations. It means the movement of particles should be free. It may be both strong and maybe a weak leakage fields, like maybe a large gap or maybe a small gaps. The part surfaces should be clean and dry before starting the inspection. How we are understanding, you see, this the surfaces where we are going to do the inspection, it should be very dry surface because we are using the dry particles. There are two methods of uh, particles of magnetizing particles can be sprayed over there. One is a dry particle spraying method. Second one is a wet particle spraying method. So in any cases, wet particles no problem, but otherwise in the dry particle inspection method, if the surface is not dry, these particles which we are spraying with these dry particles will stick over there and make some irregular results. So it should be dry, and also we are using a red color, maybe any color. Red color particles, the surface should not be maybe in contrast or should be very clean. Then only this particle migrations are and filling the flux leakage fields, the crack areas will be clearly visible. So we should. It's a very simple step. We are cleaning the top surfaces for better visibility. Cleaning and to be dry. Contaminants such as oil, grease, or maybe the scales, maybe water scales will be appear after the heat treatment process. So the sunlight, maybe the black color will be there, some ash-like types. So all these things to be cleaned well proper. May not only prevent the particles from being attracted or leakage fields, they will also interface with the interpretation of the indications. So you see here, the particles which are on the surfaces, it is going to block the magnetic particles going inside the cracks. If the dust particles are the top, the crack is here. I am sprinkling the red color magnetic particles over there. This black color scale is blocking or over the crack, which is not permitting the magnetic particles to go inside the crack. It means the magnetic flux leakage is not attracting, it is blocking, like an insulator. But you see, it is not only blocking, but also when it is in the same colors, it may interfere on the interpretation of these results also. So this and all we should avoid. So you see, if there is any cracks or maybe any porous or holes are there, or maybe if the oil or grease are present over there on the cracks, the cavity will be filled by those material. These cavities will be filled by the oil, maybe the grease, or maybe any dust particles, or maybe the scale, and then so it is it should not be visible. Visibility is reduced. So we should our intention is we should clean properly in such a way cracks or any discontinuities will be visible proper. So that is our aim. That is our first point. Part preparation. Part is nothing but specimen preparation. So that we have done now. Let us assume we have a crack over there, or maybe a paint is done on the specimen. When the paint is done on the specimen, this paint is a insulating material. We know this. But you see, if the paint thickness is in between zero point 0.02 to 0.05 mm, it is not bothering. It won't do an insulation job. It is permittable. So that is what it is given here. The non-conducting coating, it's starting with the non-conducting. You see, non-conducting is nothing but insulator. Non-conducting coating such as paint in order of 0.02 to 0.05 mm will not normally interface with the formation of indications. It will not disturb. That's understanding. But they must be removed at all points where electrical contact is to be made for a direct magnetization. You see, we have done a 0.05 mm coating over the specimen, but it is not interfering on the inspection, but it is not permitting to do the electrical contact. Interpretation is done by our eyes of contact visibility. 0.05 mm of particle is not doing nothing, but at the same time it is blocking the current passages over there. Definitely inspection is not started because it is insulated. Current is not passed over there. So some difficulty is there on the paint non-conducting paint coatings. So it should be removed. That's it. Because the paint will act as an insulator here. So it is given here. You see, it is given because their paint will act as an insulator. So this is the point. Because on any parts it is need to paint because it may corrode. To avoid corrosion we should do the painting. If you are painting, generally painting is done at the end of the industrial product completion. But in service, if the failure occurs somewhere, there also we should do inspection. Maybe the magnetic particle inspection. In such cases, paint should be removed well, right? Paint should be properly removed well, and then we should do the conducting. Otherwise, the insulating paint will be there, and we will do we will come into the contact. It will may not help you. Reduce your strength factors. So that we should keep remember. Right? Because any part it is need to paint to restore or save its working life. It's nothing but to reduce the corrosion. So that if the thickness is zero point 0 to 0.05 mm, there is no need to remove the, otherwise it should be removed. So that is what, if the thickness is around 0.0 to 0.05, it is not acting like an insulator. It is permitting the current flow. It permitting the magnetizing. If it is over 0.06 or 0.1, then we have to definitely we should remove. Painting is a non-conducting material. If it is on the less thickness, it is going to permit the passage of magnetizing. If it is not greater than that of 0.05 mm, it is going to act as an insulator. According to the limits, we have to remove those paints. If the part holds a residual magnetic field for a previous magnetization that will interface with the examination, the part must be, therefore it should be demagnetized. You see, the part or piece holds the residual magnetic field which is done in the earlier stages. It means it is done for the first time somewhere by some other inspector, and it is not demagnetized, left as it is. So that is a residue. When the next inspector comes for the second job, maybe the second in-service inspection. One is maybe in the fabrication inspection, one may be in the in-service inspection. In-service is nothing but when it is in the working condition. Fabrication is nothing but when we are developing the product. So when in the mistakes done at the fabrication stage, it should be demagnetized there, but it is not done there. We are coming back to the in-service. When we are coming near, it is showing some residual stresses there, residual magnetic field there. So that is a mistake. So it's attracting something it is doing. So it should be demagnetized every time when we are doing the magnetizing. Demagnetization to be done. That should we should keep remember. It having types also we should see separately. You see, next one we have understood about this first part. It means this we have understood what is part preparation. So part preparation we have done. Second one, it is completed. We are coming to the second one of introducing the magnetic field inside. First we have to increase the strength of the material. We are going to increase the strength of the material. So that we are doing introducing the magnetic field on the specimen first. That we are doing now. Introducing the magnetic field on the specimen. That we do now. See. Introduction of the magnetic field. Introduction of the magnetic field. There are a variety of methods which can be used to introduce a magnetic field in a specimen for inspection of the magnetic particle testing method. So what are they? They may be two categories. That is what I have given. Maybe a direct magnetizing, maybe an indirect magnetizing. It have types. So that also we have to see what are the various types of magnetizing methods are there. One is the AF is direct magnetizing. One more is the indirect magnetizing methods. So that we should see. Now, as of now, we are covering the procedure. 5 points we are covering. First part preparation, introduction of magnetic field, spraying of the particles, then inspection, then demagnetization. That we cover. These types we will go in the next part. So we should remember it is a direct magnetization and indirect magnetization process are available. So now we have done introduction of the magnetic field over the specimen. So first one part we have done. Second one introduction of the magnetic field also done. Third one we should go. Application of fine magnetic particles. It's nothing but a spraying of the particles we should do now. Application of third one. Application of magnetic particles. How we are doing here? Here also there are types. Here also we have some few types are there. You see, first one maybe a dry magnetic particles or maybe the wet magnetic particles. This is what from the beginning I'm telling. From the beginning itself I'm telling that there are two methods are the dry, wet, dry, wet. Dry will be in the powder form, maybe in the wet, maybe in the spraying liquid spraying form. But we see it is given given there itself. So this is how it will be. Maybe the red color powders are spraying, and the flux lines are in the same uniform direction, which is perpendicular. The defect which is perpendicular. Here, see this is perpendicular to the flux lines. Then obviously it is going to hit there. So therefore, some particles and some variations will be there in the flow of magnetic field. If it is 100%, some fluctuations will happen. With respect to that, we understand there the defect is available. So one or two defects are given. See, this is the first one. First defect which is perpendicular, which is possible to detect with magnetic particle inspection. At the same time, I have a parallel defect also. You see here, this is the parallel defect. It is on the direction of the flux lines. So it may not be give good results. Therefore, it is maybe information will be later. Variations will be later. If the variations are later, our chance of identification also get reduced. So now we come back to this particles. Application of magnetic particles. Particles may be the two types. Maybe dry particles that we are applying. Maybe the wet particles that we are applying. So how we are to have to do for this application? How dry particles we are told? How we are applying? See, I have given there. See, first one is a dry particle inspection. A fine magnetic particles in the dry powder forms are dusted over the test piece. Dusted means as like that we are pouring, taking the powder and we are pouring over there. Are dusted over the test piece. What are the one more method? If in case it is wet particles. Fine magnetic particles are suspended in the maybe the kerosines or maybe any liquids where the particles to be suspended inside the liquid, which is more easier to cover the large area. If you are putting the powder, it is sticking over there. If you are putting the powder here, it is sticking over there. If you are putting powder, it is sticking over there. But at the same time, when it is in liquid form, it is floated over throughout the surface. It will float. So equal thickness will be floated. Whenever maybe 10 drops or maybe 25 drops. So how many drops are there? It will be equally distributed over the surface. If it is equal, thickness of the sprayed one also will be equal. So indications of color, darkness or anything else will be equally visible. But in the powder form, when the large, more volume of powder is sprayed at one spot and low volume of powder is sprayed at one more spot, two difference will be there because the large volume will be more darker in red color, maybe the lower volume of powders will be lighter in red color. So the differences will be there, darker variations of red, which we can't able to judge which one is the correct defect. But it is not here, it is equally compared in the wet particle method. So this is how we little bit touch the same point we have to cover in there separately. As a dry particle, what are they, wet particles, what are they. So we will cover those things also. As of now, in the procedure, dry and wet. See, it is given a dry particle applications. Fine magnetic particles in the dry form are dusted over the test surfaces. Dusted over the test surfaces. In this technique, dry particles are dusted onto the surface of the test object as it is magnetized. After magnetizing, we just pouring over. You see in this image, we are using some pressing type to like air pushing type to force the magnetic particles to spray over the surfaces. When the electromagnetic yoke is used, the AC current creates a pulsating magnetic field that provides a mobility of the powder over because it is going to attract after application of magnetic field. When the magnetic field is already applied on the specimen. That is what our second step. Now we are spraying the magnetic particles over there. This magnetic field which is already available in the specimen is going to attract these powders and accumulate at one point where more leakage crack is available. Otherwise it is really uniform. When the crack is available, it is going to attract at that point more powders. So that we understand more powder is there, that is become the crack. This dye particle inspection is also used to detect a shallow subsurface also. Basically, it is a surface defecting method where what are the cracks available in the surfaces. This is surface, it is connected to the surface. But also the crack available are nearer to the surfaces is also possible. But it is not possible which are more uh, deeper in the points. Dry particles with a half-wave DC is the best approach when inspecting a lack of root penetration in welds of thin materials. Some examples. Suppose we have a crack at the top of the material. Let us assume we have a crack here. You see, let us assume we have a specimen and we have a small crack over there. Okay? And if we are having a crack over there and we are putting some powders, magnetic particle powders equally distributed. Let's assume your particles are equally distributed. Due to the flux leakages of the crack available in between, due to the leakages of the flux lines, here the flux lines are there in the uniform direction. Right? The flux lines are there in the uniform direction. Here there's a crack, therefore here more flux lines are leaking. It is going to jump and it is going to go over there, right? So this leakage of flux lines will attract these powders which we have manually poured over there, and it will accumulate at this point, more accumulated. You see, it is more accumulated because it is more field is coming out, and therefore more attraction will take place there. So that we can easily found. So that is what the point written. Putting a ferromatic particle, the magnetic flux will attract the magnetic particles. So it is going to attract the magnetic particles. When it is cleaned out, easily the cracks are visible. So because it's attracting, it is going inside. It is went inside and it is filled over there. And we have to clean up. When it is cleaned, it is obviously all will be looking good. So we are going to clean. So when it is cleaned properly, so the particles which is available at that which is went inside will be visible now on the surfaces. So with respect to that, we can able to easily, so here it will be visible. So it's at the surface. So our surface will be visible. We can able to find the defects. You see, because the ferromatic specimen, if some kind of a colored ferromatic particles, you can easily detect that where the cracks are present on the surface. So maybe a red color, or by my diagram it is in yellow color. Practically it is in the red color particles will be there. So I'll play one video also. So this is what the yoke method. See the images. We are applying the yoke method, following method, and then they are on the weld zone, weld track lines. They want to find the cracks. So they are keeping some various images here. You can see how they are using this simple method of having a yoke at hand, magnetizing, keeping spraying, keeping spraying, keeping spraying. So likewise, they can easily detect. Second one, a wet method. As of now, we have seen application of magnetic field. That is, one is uh, dry method and one also wet method. Dry method we have seen spraying the powder. Second one, wet method. The wet magnetic particles are suspended on the liquid. So that liquid is nothing but here, as of here, it is kerosene or any other liquid can also we can use. A wet magnetic particle inspection. Wet magnetic particle inspection are more commonly known as wet suspension magnetic particle inspection. So wet magnetic particle inspection, otherwise we are calling that as a wet suspension because it is mixing with the water. It involves applying the particles while they are suspended in the liquid carrier. So and then the liquid will be uniformly distributed over all the zones of the specimens, equal in length, equal in thickness, equal in volume. Wet magnetizing particle inspection is mostly performed using a stationary, a wet, a horizontal inspections only. Why it is horizontal? Because when it's vertical condition, the liquid, all the liquid is going to go down. There is no other way. Particles may not be there due to strong or weaker conditions. So it is recommended only for the horizontal specimens. The stationary specimens, not the moving or vibrating, all those things cannot possible to do. But the suspensions are also available in the spray cans. So for these difficulties, they have now small spray cans, density increased spray cans. Just like that, when we are spraying, the suspended particles will sprinkle and sticking over there. So the methods are now they are finding. Spray cans are used with the electromagnetic yokes. So that is how we understanding the dry particles and the wet particle inspection. You see here in the images, they are doing some specimen is available, and they are sending the liquid form suspended magnetic particles over the specimen. It is going to float now, and then we can do the inspection. So the wet particle applications advantages are there. What are they? All the surfaces of the components can be quickly and easily covered. Why it is quickly and easily covering? Because it is uniform layer forms. That is why that it is given there. You see, it is a uniform layer particles because it is a floating, not like a dry powder. That's a limitation for dry powder. The liquid carrier provides mobility to the particles for an extended period of time, which allows enough particles to float to a small leakage also, and fails to form a visible indications. Yes, therefore, wet inspection is considered the best for detecting a very small discontinuity on the smooth surfaces. You see, in the particles, dry powder we are putting over there, it may stacking over on the surfaces that it will not go deeper. But as compared to the wet particles, definitely the liquid will find all the zones and goes into the field of inside. So it is more recommended than that of the dry particles. But we are using spray, it is horizontal, vertical, overhead, possible. On rough surfaces, however, the particles which are much smaller in the wetting suspensions will settle in the surface valley and lose its mobility. You see, the surface should be somehow it is a smoothness to be there. Smoothness to be there. If the smooth is not there, what happens? It will the liquid with whatever we are spraying over there, whatever we are spraying over there, it will be stuck on the non-smooth zones. If we have like a irregular form of specimen, irregular form of some cavities or valleys are there in the specimen. So what happens when the liquid is sprayed over there? It will be stopping here. It will be stopping here. It will be stopping. It will not float. It will not float. So therefore, we understood we need some smooth surface. Flat, horizontal, smooth surfaces are needed for the wet particle inspections. So now, as of now, we have completed a participation, introduction, introducing the magnetic field, application of the particles, and the examination. So that is also we are doing now. See, third one, examination of the component surface. It means we have completed field created on the specimen, particles sprayed on the specimen. Now only we have to inspect. We are going to check what happens, whether it is the red color is visible, where it is visible. That spot belongs to the crack part. See, when the fine particles of the magnetic material is applied on the surface of the test material, leakage fields attracts the particle, which forms an outline of the discontinuity. So here it is cracked, then outline will be there. So whenever let us assume a 2D diagram here. See, when the crack is available here, let's assume this is the crack zone. So some cracks are there perpendicular to the flow lines. So now, what happens? Uh, these zones, when we are applying the particles, this cavity is filled by the particle. Now, that color is visible there. In our PPT, it is in yellow color. It is visible to our eyes. Likewise, the particle is the red color. The stainless steel will be in the other color. Therefore, it is visible. So, you see, it shows the outline. It shows the size, how much it is bigger or smaller. So it shows going to shows the size and what is the shape of the discontinuity, maybe irregular, circular format or any design. So irregular format of cracks, how it is available, how big it is. So all the informations we are gathering from the formation of the red crack. So maybe visible particles clustered formed at a specimen surface are viewed under white light. Maybe fluorescent particles are viewed under the black lights. So there are two kinds are there. Maybe dry particles, maybe the visible form, suspended maybe in the fluorescent forms. Maybe fluorescent lights are visible on the black lights. One is in the visible particles, white, fluorescent particles, black lights, UV lights. May also we can use. So if there is any cracks or pores on the top, you see, When putting magnetic particle over the top, only through the crack the leakages magnetic field will come out and it will be attracted. So easily we can found that the cracks present because it's attracted to our eyes, accumulated to one point due to air leakages. It is easily we can able to find the crack options. This is about the examinations. So some examples are there. Say a visual wet or dry particle method. So maybe it is called as visible or dry. So here we are spraying a surface defects on the gas pipelines. So some examples I have given you, some photos of the how it is done. You see, surface defect on the gas pipes, and this zone cracks in the seal weld of a boiler tube to a steam drum. Maybe this is the lack of cushion in the some shielded, sorry, manual metal arc welding, that is otherwise called as SMAW weld zone. So here there are cracks are there. So at this point, the arrow, this arrow point is belongs to the crack here. This point, undercuts are there. More undercuts are there. And the last images, you see, throat and toe cracks in partially groundward. So here are it is in the picture itself. It is visible here. So this spots all belong to the defective discontinuity parts. When you are applying the magnetic particles red color, it is filling those gaps. After cleaning, we can look over the first defects. Maybe if it is a fluorescent method, you see, when we are seeing this crank hook without the fluorescent light, black lights are there. It looks very good. It is when if I am an inspector, I will tell okay for this because without inspection, this looks very good. I definitely will tell okay. But at the same time, you see, a nearby image, when I am looking for applying through the UV rays of light, it is showing a crack there. This is the crack. Then it is not okay. I'm rejecting this specimen. See one more example. Here the gear with the service induced cracks. So here it is okay. So it okay means without inspection, it looks very beautiful and it neat. But at the same time, when I'm doing the inspection through the fluorescent wet particle method, it is showing the crack here. Reject. Okay, so likewise it is possible to do. So let's see one more example. Drive shaft with heat treatment induced cracks. So here it is not visible, but here some few all are visible there. See the large bolt with the service induced cracks. Here it is not visible. It is okay, but it is not okay here. It is not okay. It is not okay. So likewise, it is we are doing some inspections maybe through the dry particles or maybe through the wet particle inspection methods. So at last we came to the last point, that is nothing but demagnetizing methods. Right? Out of 5 steps, I told you. First one cleaning, next one application of magnetic field, then application of magnetic particles, then the inspection, then at last we have magnetized already on the second stage. So on the last stage we have to demagnetize also. The parts inspected by a magnetic particle method may sometimes have a objectional residual magnetic field that may interface with the subsequent manufacturing operations. What is subsequent manufacturing operations? What does it mean? Subsequent manufacturing operations. You see, I'm doing a casting process and I'm doing a magnetic particle inspection method to do find a crack on the casted object, and something is not there or available or present or absent. No, that's apart. And then the same product is taken to the fabrication of boiler plant after casting of the plate. There I wanted to do, there I wanted to do a arc welding process. If I want to do the arc welding process, you see there we are generating ionization process. I think we have learned. We are sending the supply of current, direct DCEP, electrode positive, DCE electrode negative, and then I'm generating a arc in between these workpieces, magnetized workpieces, and the electrode. When again I'm sending the current there. So what happens? The arc blow happens there. It means this arc this arc is nothing but ionized gases. So it will fluctuate over there due to its already magnetizing conditions. We don't know that unfortunately in the previous subsequent manufacturing stages in the casting it is magnetized, it is not demagnetized. Unknowingly we are doing again some welding treatment there, but the arc flow occurs there. Arc is fluctuating due to its magnetizing power of the workpiece. That makes a defect again. Arc flow is a defect, a heavy defect in welding process. It's unavoidable then. So what we have to do, we have to demagnetize in the previous stage in such a way we can able to avoid this arc flow in the subsequent welding treatments. Not only welding, any other process also. Not only arc flow, any other defect also. Right? So that is how we are getting some demagnetization is very important. See? That is why subsequent manufacturing process or service of the component should be avoided. See, a retained magnetic field is depend upon how it is depend. Maybe the magnetizing characteristics of the component, maybe a stainless steel or maybe iron particles or nickel alloys or cobalt alloys, any material, magnetic properties there to that material. So depend upon that if it is not magnetized or magnetized, it will lose it or not lose it. So that is the magnetic characteristics of the component. Depending upon it, the residual factors also will differ. Then the geometry of the component, then the direction of the magnetizing, whether it is doing the clockwise or anti-clockwise, in which direction we are doing, according to that opposite direction, we should do the demagnetization process. If you are doing in the same direction, the same similar magnetization will not go. If you are doing the left to right magnetization, we should do demagnetization in the right to left. That is the procedure. To do demagnetization methods that we have to follow. So that is what it is. The third point given, direction of magnetization. If, then the last point is strength of the magnetic field. How much we are giving to generate the magnetic field? We should not only the permanent magnet, we are going to supply the electromagnet also. So for that current we have to supply somehow from 20 to 50 amps are required. So depending upon the current amps application, the field also changes. The current increases, magnetic field also increases. Current increases, field increases. So that is what the strength. 50, 60, 70 amps we are giving the current, then the magnetic field also higher there. If you are giving some 20, 25 amps of current, then the magnetic field also is getting reduced. So that is how the residual magnetic field formed on the specimen, which should be demagnetized. So that is what the fourth point we are doing on the procedure demagnetization process. We have done now. So for this also types are there. It affects the machining. If it is magnetization is there, it is not it is not demagnetized. What it will do? For examples, I have given few. It affects the machining process. The cutting tools maybe stick to the component. I want to do machining process. It means the subsequent manufacturing process, something I'm doing cutting process after casting. I'm machining, I'm changing the shape of the product. What happens? This cutting tool, due to its magnetizing ability, it will stick to over there. It will not um, cut the process. Treatment will not be takes place. Treatment will not be made. So that is one of the importantly bad thing. Next one you see The placing interface with the navigational instruments that are sensitive to magnetic field if placed at close proximity. So that's what the point what I told arc flow it can create a condition known as arc flow in the welding process. What happens? See what happens? The arc flow may cause the weld arc to fluctuating, wander around a filler metal to ripple the weld. So it is not actually welded process, not take place. It's rippling from the weld, so welding conditions. It's rippling out. It's not melting and the droplets are not over the material. It is rippling somewhere. So welding not occur. This causing the cause of abrasive particles to hang on the bearing or fine surfaces increase the wear. Somehow we are doing some abrasive treatments, grinding operations. So the abrasive particles are having some magnetic ability, and it is a specimen is already magnetized. It is not demagnetized. Where we want to do grinding operations, we are coming nearby. It is keep on in contact itself. So it is increasing the wear property. It is increasing. It is not when it is not coming out. So maybe the wear may increase, or maybe it's sticking to the component, or maybe the arc flow increasing, so it may be rippled from the weld. Some lot of mistakes may happen. So importantly, we should do this demagnetizing treatments. So method of demagnetizing. Initially, as created the magnetic flux for inspection that have to destroy the magnetic flux. Yes, magnetic flux is created, that we have to destroy also. By doing demagnetization, it can be used that particular material without any residual magnetic field. That is what point you should keep remember. Without any residual material, it is as it is very fresh. There are two types of magnetization, demagnetization. Or maybe one is a heating method, maybe one is a electrical method. These two we have to see separately. Maybe heating method and electrical method. Types of demagnetization we should see separately. And now it means at last point, demagnetization, fifth point, demagnetization is done. Process completed. So now we are coming to the last point of advantages and disadvantages. You see, first I am reading the advantages. The rapid and economical compared to the other process, because it is quickly we are getting magnetizing, and then we should pour the particles. It's going to attract. We are going to get the result. So it is very simple. A staff can easily train and operate. So, unskilled laborers can do this. Magnetization only one click of button, the current is going to pass, field is going to create. At the same time, I'm going to one more hand. I'm going to spray the powder. So easy training. No need is there. I'm going to mark over the signals what it coming up. It can detect both surface and subsurface defects. It can able to detect both surface and near subsurface, not the longer distance. This is the surface and this is the subsurface, not this one, not this point. Okay, so it is easily and can be rapidly we can done. Inspect parts with irregular shapes. Any shapes, no problem. Just we have to create a contact. Just we have to create the pass the current, create the fluid. Pre-cleaning of the component is not much critical. Very easy at the surface we can do. Inspection and indications are fast, visible directly on the specimen. We can able to see after the red color. But the one limitation is there. The inspector should go nearer to that. Because it is visual inspection, we have to go nearer. But in the case of radiography, film, the film taker operator is different, inspector is different. Only inspector needs the film. So the operator will operate the radiography and they will clean the film and they will give the film to the inspector. Just by viewing the film, they can interrupt the results. But it is not like that here. Here, magnetic particle testing, inspector to visit directly the spot, the specimen. Then we can able to identify. portable easily as used with the battery powered equipment? Yes. So limitations, a few similar limitations are there. You see, use only on the ferromatic material? Yes, not on the plastics or not on the other dimatic paramatic materials. Unable to inspect non-ferrous materials such as maybe not are possible to aluminum, magnesium are not possible. Iron, importantly, iron, nickel, cobalt alloys. Only effective for seeking surface breaking or near surface defects. See, here they are told inspecting possible on both surface and near surfaces. But at the same point here, the limitations only it can able to do surface, subsurface, not on the deep surfaces. Only the near surface possible to inspect. So that is one of the important limitations. Specimen must be magnetized at least in two directions. What we are doing to complete the coverage. First we have to do in this direction and again we are in the opposite direction to demagnetize it. So both we have to do. Must be demagnetized again. That is the point we have already lot of times we have done discussions. Different magnetic characteristics of base metal are difficult to inspect. So maybe sometimes the magnetic property may differ. Each material may have a strong magnetic property. Some material may have a weaker or lighter magnetic property. Each thing we should give some application of current may vary, lower, higher. Such things some understanding required. That may be limitations. So definitely at last we should do the cleaning process because the particles we are keeping there first cleaning then only it is visible. After the visibility that also to be cleaned. If it is not cleaned it will be residue red color. Not only the energy, the powder color particles also visible may become residue and it will interrupt on the later secondary inspection. So this we should keep remember. So these are the advantages and limitations of this magnetic particle inspection. Applications. You see, generally is used magnetic particle inspections are used in the industry with respect to inspections of stainless steels, maybe in the automobiles, maybe in the petrochemicals, maybe in the power generations, maybe in the aerospace industries, maybe in the underwater inspections in the area of offshore structures and underwater pipelines. Or wherever it is, we don't bother. But the content is it should be a ferromatic material and it should be helpful to do this inspection. So that is what the only condition we should keep remember. Right? These are the various cases that this procedure to follow for magnetic particle inspection. Now I would like to give you a small a video clip. It is open source taken from YouTube, but will be helpful for our understanding of what we have learned up to now. Right? I am playing the video, which is a YouTube video. Please have a look.
In this video, we will give you a demonstration of the dry powder magnetic particle method. Here is the AC yoke. The first test is to check the lifting capacity of the AC yoke. So here we go. This is a 10-pound weight. The test is successful. That means the yoke is good to go. The next step is to check the light level on the surface of the part being inspected. You can see that the light level is more than 1000 lux, and that is acceptable. Here we check the magnetic flux intensity or the magnetic flux adequacy using a pi gauge. Here we go, and you can see very clearly that the lines which are normal and at 45 degrees to the magnetic flux are very clear, and the line that is parallel to the magnetic field is not visible. Now we are ready to do the magnetic particle inspection on these two plates. We place the yoke, apply the dry particles, and have the yoke on. And then what I'll do is I will use the blower to remove any excess particles. And you can see the indication starts to show up. Here is the indication in this plate, which is right at that location. The indication is about 6 to 7 millimeters long, and it's very clear, which is right here. And then I'll go to the second plate, do the same process, apply the magnetic field, sprinkle the particles, and then remove the excess particles from the plate, and then the indication shows up very clear. Here is the indication, and the length of the indication in this case is 22 millimeters. Again, it's right there, and it's about 22 millimeters. The dry powder inspection is very simple, easy to use. One of the main advantages of the dry powder is that it can be used at high temperatures up to 600 degrees. And again, the most important things in this inspection are to make sure the yoke is good and there is enough light on the part being inspected. Now we will go to the next two videos, which will be on the wet empty. The first one will be on wet visible empty, and the second one will be on the wet fluorescent empty. Thank you.
Thank you. See, this video is
Imagine
taken
sitting
from
inside, glued to
YouTube
your
only.
computer. The sun is shining, the birds are chirping, but you don't care. In fact, you can't look away. It's not hard to imagine, is it? That's because, right now, you're the proof that doodle ads like this one work. And it's not just you. People love them because they grab and hold their attention.
Thank you for watching. This video has been taken from the YouTube only. It's from the open sources, and it helps to us to understand this magnetic particle testing. The remaining part of the subjects, we'll see you in the next session. Thank you.